Morning, guys. Hi, Ron. Hi, Jack. Hi, Hayden. Hi, Rainey. Hi, Azra. Not a new setup, but new intro. New outro, too. Hi, John. Hi, Kaylee. So you can see the agenda in classroom. Pretty straightforward day. Goal is to kind of finish up the study guide, review it over the weekend, prepare for a review on Monday. All right. Um, just start with some news in that we started a new month. What are some astronomical events going on in April? So AccuWeather put out an article about what you could look forward in the night sky this month. Then we'll do a review of parts 2 and 3 of the study guide, numbers 5 through 9, and then we'll do 10 through 14. I'll do 11 and 12 with you. So 3 of those 5 are going to be kind of on your own, writing on your own. But I'll provide some guidance when I get to that section. All right? Everybody doing good? Yeah, that's better. Cut out the side bars. So if you've been outside recently and you look up in the night sky, in the evening sky, especially when it gets dark, um, first you see the moon. It's pretty obvious, starting to wax, and then you have another bright star in the west sky. That's not a star at all, even though it's called sometimes the evening star. It's the planet Venus. And then if you look a little more south, so to the left of the moon, I don't want to say new moon, but the waxing moon, you would see the constellation Orion. And Orion is kind of setting now as we're entering spring. Orion is a winter constellation because of the Earth's tilt and its axis. You can't see all the stars at all the time, except you can see some stars, like the North Pole, and the stars around the North Pole. Those are called circumpolar. They're always out. You can see those constellations all the time. But Orion rises in the fall, sets in the spring. Usually, a constellation that is kind of like the opposite of that I think of as Scorpio. Scorpio, the scorpion, looks like a J in the southern sky in the summertime. Scorpio is going to start coming out pretty soon, later on in the night, and then eventually it'll progress through the night sky and start to set end of summer, kind of when Orion then takes over. So Scorpio and Orion kind of mark. That's how I think about mark the summer and the winter seasons. Hey, John Leach. So how about April now? What's kind of happening? You can watch the AccuWeather video. Yeah, they're hit and miss. They don't really have much to say other than what they already have in their article. All right. Springtime stargazers will have plenty to look for throughout April, ranging from a meteor shower to the rare opportunity to see a comet. Meteors and comets. We'll get to what they're talking about. Maybe a little hype right there on that comet. We'll see. The wide variety of astronomy events this month will be great for people looking to spend some time outside under the night sky, including families with young children, as they'll not require any special equipment apart from a blanket, warm clothes, and a clear sky. So you can do this while social distancing. You don't have to be with other people. You can be outside and just look at the sky. All right. So top 3 events that AccuWeather is kind of putting out. And again, AccuWeather, why are they putting out astronomy news? Because they predict the weather. You need good weather to be able to see the night sky. No clouds, no storms. So you need high pressure, right? So the first one, super pink moon. I know people have asked about, what about the supermoon? What about the supermoon? We know about full moon. What about new moon? What about supermoon? Well, the supermoon is a rare event. Our next full moon, April 7th to April 8th. So we got 5 days. All right. We're currently in a little over first quarter phase. So we're almost there to full moon. We're waxing. We'll have a gibbous tonight probably and into the next several nights. All right. The full pink moon, also called the fish, egg, or sprout moon. Don't know where the names come from. If you know, let me know. Moon is at perigee. That means the moon is at its closest approach in its orbit around the Earth. Because again, the moon does not have a perfect circular orbit. It's kind of egg-shaped. It's elliptical. All right, so it's kind of rounding the closest point in its orbit, and it just so happens to be happening at the same time of a full moon. So it's opposite the sun. It's kind of like a hula hoop going around and around. All right, it's changing where that perigee and apogee, the furthest point, is around the Earth. All right, time of maximum fullness varies with viewer location. So astronomical full moon is going to happen at a very precise time. It may or may not be at nighttime. So we got to just be aware that, it may, if we go to like timeanddate.com or if you Google when's a full moon, you might get instead like a waxing or a waning gibbous a couple minutes after the actual full moon. All right. Hayden says it might be because sailors would see them while fishing and then name them after fish-like things. It's a good explanation if I didn't have one. Why is the full moon called a fish moon in April? So it kind of looks like, so maybe not European sailors, but Native American fishermen. Yes, I'm going to continue that. The worm moon, full pink moon. So it's when fish would spawn upstream, so like trout, salmon. Also associated with Easter. Yeah, type of fish spawn. Yep. Yep. Interesting. So all different moon names come from different cultures or different events with ecosystems. Nice. All right. So we have a supermoon. This one called the pink moon. Right? So if I could just kind of just emphasize with you, right, that we have our Earth. Hi, Charlie. Yeah, that's, there we go. I want to emphasize the non-perfect circle nature. So we have our moon, who's kind of at this point. Sun would be over here, right? Moon's going on a counterclockwise orbit. So right here would probably be the closest, and right there would be the furthest. This would be perigee. This would be apogee. This perigee is coinciding with full moon because it's opposite the sun. All right. So just kind of showing you. So then the new moon would have been at apogee this year. This month. We are just taking a look at an article on AccuWeather about different astronomical events, the top 3 things that you could see in the night sky in April. You don't need anything. You just go outside and look at the sky. So you don't need to go anywhere or have anything, Charlie. And then we're going to go over parts of our study guide so that you can get most of it done today. Oops. So that's the first thing. A supermoon, it'll just look slightly larger. It's not going to appear pink, so don't think it's a lunar eclipse. The pink, again, just coming from spawning fish. Or a flower now. So fish and flowers. All right. Full view of the pink moon. This kind of looks like a lunar eclipse. It's not going to look like a lunar eclipse. Second thing, which definitely very cool to see, and you might be able to see it considering we have flexible starting times. Don't know, your bedtime might be more flexible here in that you could probably see this because meteor showers tend to peak later on in the night. April 22nd is known as Earth Day, and the global event will kick off with a light show from Mother Nature as the Lyrid meteor shower reaches its peak. Now, meteor showers receive the names after the constellations at which the meteors look like they come out of. What's a meteor? It would be no more than like a little grain of sand, so a little piece of pebble rock that's flying through space, enters the Earth's atmosphere, and the friction with the Earth's atmosphere and the material of the meteor will then catch on fire and cause a streak, and that's what you see as a shooting star. So, shooting stars. All right. This is the first major meteor shower since January and will bring 15 to 20 shooting stars per hour on the night of April 21st into the early hours of April 22nd, so towards the end of the month. This year will be a particularly good year for the Earth Day meteor shower as it occurs on a moonless night. So we're going to do it around new moon, which is really nice because you don't want the bright full moon or waxing or waning gibbous in the way because then you can't see as well. All right, meaning darker skies for onlookers. These meteors are best seen from the northern hemisphere, where the radiant is high in the sky at dawn. So from the constellation Lyra and Hercules, which I believe is kind of like in your northeastern sky. All right. So you look in the northeast, you'll see these stars kind of coming out from that central location. Most meteor showers are actually the debris of comets as they pass around their orbit in the solar system. So I'm not sure which comet is responsible for this one. No, we're not going to end up with a terrible fate, John. We'll be all right. Folks that missed the Lyrids will only have to wait about 2 weeks for the next chance to see a meteor shower. The Eta Aquariids set to peak during the first full week of May. I'm not familiar so much with that one. The Geminids will be a big one, and then the Orionids later on in the year. Those are big meteor showers too. Third thing, this one might be a little overhyped because I always get hyped for comets. Me and my wife would go look for some of them, never find them, even though I have a telescope. Still unable to find them because they're not very bright. So astronomers like to hype up comets because they look really cool, but they don't always pan out the way they hope. A newly discovered comet, which again is a large, almost like an ice ball in the solar system, leftovers of planet formation. They have very crazy large elliptical orbits. So, just quickly, here's our sun, Earth all the way out here. Just for reference, Mercury's there. Put Jupiter out here. These comets, they come in at crazy elliptical orbits. And so when they get close to the sun, their ice starts sublimating and they produce tails. And they either come from a place called the Kuiper Belt, which is outside Neptune's orbit, where Pluto would be, or even further out called the Oort cloud, named after astronomers who found them. All right. Leech, you're going to have to kind of explain to me what a sad G noise is. Comet Atlas, known as Comet C 2019-Y4, was discovered on December 28, 2019 by astronomers using the Asteroid Terrestrial Impact Last Alert System. So it's our warning system. Atlas in Hawaii. It is still too dim to see without a telescope, but is expected to get much brighter in the coming weeks as the ice, the coma of the comet, starts sublimating as it gets closer to the sun. All right. If predictions are correct, Comet Atlas might reach a visual magnitude of +5. That's kind of dim. Positives are dim, negatives are very, very bright. So something like Venus is like in the negatives magnitude. All right. Around May 1st, so end of this month, beginning of next month, that is theoretically bright enough to be seen with the eye, but the fuzziness of faint comets can make them harder to spot. Yeah, no kidding. If you have binoculars, try going out tonight, take a look at the first quarter waxing gibbous, or later on in the month, try to find a comet. All right. Spot the comet, look at the northern sky. It's not far from the Big and Little Dippers. So find the North Star. You might find this comet. Big Dipper is probably easy to find too. All right. Closest approach on May 23rd, and then closest approach to the sun is May 31st. And they just kind of go back into the equinoxes, the earliest since the 1800s, late 1800s. But you can do that reading if you want, because we're going to talk about equinoxes today. All right. I'll go to those things towards the end of the stream. Ryan, Jack. All right. So we went over part 1 yesterday. You worked on part 2. I gave you some direction on how to do part 2 and part 3 yesterday. Part 3 was short, pretty much just using the lunar diagram, breaking it into pieces. All right. The first half, drawing where the moon is around the Earth according to its phase, and 9, just drawing what the 8 phases look like from the Earth's point of view. So taking that diagram, breaking it in half. Pretty simple there for lunar phases. Be able to obviously know where the moon is around the Earth at certain times, and then be able to identify phases. That's the key takeaway here for each question that we gotta have for the test. All right. Part 2, what causes seasons on Earth? How does it cause them? Yesterday, I was kind of talking with Eric in chat. He came up with that, and Azra helped him out get there, that we're looking at tilt. All right. The tilt is going to cause a change in the angle of light on the Earth from the sun. All right. More direct light is going to produce more energy, and then more indirect light is going to produce less thermal energy, change the climate in that area, and that's where you end up getting summer and winter. All right. Get more in detail down number 7. Number 6, draw a diagram of the Earth revolving around the sun at 4 different points according to the season for the northern and southern hemisphere. And I mean point as in obviously points of a compass. All right. So think of a points of a compass, put a Earth around those 4 points. All right. And so I had a diagram, go back to March 5th in Google Classroom in the stream. That diagram, those notes would help you obviously complete this question. But if you want to see it quickly one more time, sun is here. I draw a big orbit around the sun. That's obviously for the Earth. This is, again, number 6 on the study guide. If I draw a big circle, which is the orbit of the Earth, I cut the orbit into half vertically. I cut the orbit in half horizontally. At each intersection, I am going to draw an Earth. All right. I have to put the tilt in the axis. I'm going to tilt our Earth this way this time. I think yesterday I did the opposite. Just showing you that it's based on the tilt, not where the Earth actually is. I mean, it's a tilt plus where the Earth is, but obviously the tilt's the primary way. So this solid line is going to be our A, our axis. Dotted line, I'll make the equator. Northern hemisphere, northern hemisphere, northern hemisphere. All right. This first one, I'll give it a letter. A, B, C, D, because I'm going counterclockwise around the sun. At A, the northern hemisphere is tilted in towards the sun, right? So if I draw sunlight coming in, 5 lines, most of the light is in this northern hemisphere, all right? If I go opposite, okay, most of the light is in the southern hemisphere on the opposite point, all right? They have a social distancing emoji. I'm glad you guys are paying attention, clearly. Finding more emojis. Anyway, more direct light in the northern hemisphere at point A. So if there's more direct light, and there's just more light in general hitting the northern hemisphere, we're going to call this summer. Call this one winter. Obviously, light is not equal, so this is a solstice. All right, going from summer to winter, then we have to have our trees turn colors. Daytime is equal because, like I did for John yesterday, if you draw those 5 sunlight lines, you can't tell if it lands more in the north, more in the south, because the axis is parallel to the sun. Therefore, it's going to be equal, so we call it an equinox. Okay? Autumnal equinox, go from winter to summer. You got to have your flowers bloom like right now. So this is spring, but we're going to call it the vernal spring, the vernal equinox. Timing on average happens around the 21st of the months, but it doesn't always on exactly the 21st. Summer, June, winter, in December. 3 months after summer, you're in September. 3 months after December, you're in March. There's our summer solstices, winter solstice, vernal equinox, autumnal equinox. Now, so do I put this in for question 6? I would include it if you haven't already done so, Ryan. So I just want you to obviously remember that all these points are opposite for the southern hemisphere. Everything is opposite. So this would no longer be the summer solstice at A. That would be the winter solstice. Oops, I didn't see that. I was in the way. So that would be the winter solstice at A, and it would be the summer solstice at C, if we were talking the southern hemisphere. Okay? It's all flipped. Well, try and make a better diagram, like this diagram, Ryan. If you want to do it on paper, because paper's neater, it's hard to use Google Draw. If you're having trouble with that, go ahead. I prefer you don't screenshot it and just insert it in, because then you're not going to be the one who's doing it, taking its time to go over the information and try to integrate it into your head. All right, that was 6. 7, describe daylight angle and length during the summer solstice. Describe daylight angle and length during the winter solstice. How do they compare to the two? Did this one yesterday. I want to jump over to parts 3 and 4 really soon, so kind of quickly. I mean, you can go back to yesterday's stream. I'll post, or I can just pull up the screenshot from yesterday. Let me do that while you guys... Where is it? I thought I had a screenshot of what we did yesterday. Well, we can describe daylight angle and length during the summer solstice as, obviously there is more daytime in summer. There's more light. You can even use that from number 6. There's more daytime, more daylight, and the angle is more direct. Okay, daytime is greater than 12 hours. Everything is greater than 12. All right. For winter time, the winter solstice, daylight is less than 12, regardless of where you are in latitude. But in that hemisphere, you are less than 12. A little more extreme the more further north or south you are towards the pole. But again, indirect light, less light in general, less than 12 hours, produces a colder atmosphere, colder climate. All right. For the equinoxes, autumnal and vernal, equal 12 hours of daytime, 12 hours of nighttime, mix of direct and indirect light. An almost even mix, but not quite. All right. So that was what we did yesterday, what I wrote out. Mr. G, do I have to label the phases for 8 on the diagram? Because it is hard to do. So let me just kind of go down to number 8. Draw a lunar phase diagram that shows the moon's position around the Earth. Do I have to label the phases for 8? What do you mean it's hard to do? Like you physically can't fit it onto your diagram, or you just don't know how to do it? You got to be able to number them in a list then, which is kind of what 9 is anyway, though. So I'll quickly do 8. The text boxes are very annoying. If you want to put numbers next to them and you want to make a little text box, a big text box next to it, numbers 1 through 8, fine. But I mean, you're going to do that at number 9 anyway. It's a terrible orbit. Initials are fine. Because I'm assuming you know what the initials are. Just be careful with waxing and waning. You're gonna have to kind of you're gonna have to do wax or wane. Wan. There you go. That works. So I'm kind of just drawing that lunar diagram. It's not gonna be perfect. Again, the better version, which you should already have done too, is in Classroom. So I think I said March 10th. Yep, March 10th. All right. So we are moving in a counterclockwise revolution. Going to take 28 days. So each one of these quarters is 7 days, right? This is 8. All right. So this is for 7 days. Obviously, the phase closest to the sun, like even without even trying to look at, is this half full light? Is this half all night? Is this a mix? If it's a mix, is it mostly day or mostly night? Like I don't even have to like think about that if I just remember. Forgot to add that in. If I just remember that the phase, the moon closest to the sun, is going to be new moon, and the phase opposite new moon is automatically full moon. All right. And by doing that, I already kind of can then figure out where the quarters are. Because if I go 1/4 in the phase around the Earth, then I know that this is my first quarter up here. And then if I go 3/4, then I know this is. That's terrible. And you don't think you can even see it because that drawing number gets in the way. 3rd quarter. All right. No, we don't have a 2nd quarter because then that's full moon. We already have a name full moon for. And no, we don't call new moon 1st quarter because we start at that point. Okay. Sometimes you might hear 3rd quarter referred to as last quarter. I'm calling it 3rd quarter because it helps you remember you go 3/4 of the way around the Earth, it's 3rd quarter. All right. When you go from new moon to first quarter, you are gaining more view of the daytime, right? Because there's no daytime here, some daytime there, more daytime, even more daytime, completely daytime. This is all, in this section, waxing phases, and these are the waning phases. All right, so this right here, starting from new moon to first quarter, that's automatically going to be a crescent, and going from third quarter to new moon is automatically going to be a crescent. Okay, gibbuses are near the, or gibbi, are near the full moon. All right, and if we're waxing on this side, then this is the waxing crescent, this is the waxing gibbous, this is therefore the waning gibbous, and the waning crescent. Okay? Again, I'm doing this quick because you should have this diagram in classroom and you should have already had it done. It's just confirm that you did this right. Okay? And so I can kind of quickly do this by just remembering that new moon is closest to the sun. If I put the sun on the other side, then new moon and full moon flip, and all these phases are going to flip. Okay? It's according to the sun. Just like the axis tells you what season you're at, according to the sun. Okay? So it's the tilt and the sun in the seasons diagram. It is the moon's position and the sun for the lunar phases. And that is nature. Okay? That's why I flip the diagram on you a lot of the time, because I want you to see that it's based on these natural things that we observe. All right? So that's 8. And then 9, I already have a list. I'm already at 10:30, past 10:30, so I want to get to the other parts. You can go to the diagram in March 10th, so I'll show you, right? If you scroll down to March 10th, this is March 30th, 27th, March 13th, 10th. Phases, that was the warm-up, but that was also a... Where was my diagram? Ooh. Should have been March 11th. My bad. So if I misled you, I'm sorry. March 11th was our big diagram, right? So this is what I already made, except I put the sun on the left, and it just shows you number 1 is new moon, number 5 is full moon, right? So if you flip the sun, you flip the phases. New moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent. You can't go gibbous, full moon, crescent. You can't go from almost full to barely full at all. That makes no sense. So gibbuses bookend. They're on either side of the full moon. Gibbi are on either side of the full moon. All right. You can also think of it as then crescents are on either side of the new moon, because remember, this repeats. I mean, we write it as a list of 1 through 8, but 8 just immediately follows. 1 immediately follows right after 8, and it just keeps going around and around and around and around and around and around for billions of years. All right, every 28 or so days. Okay. That's what they look like. Again, I'm shading in the night version, or the night side of the moon. I'm not shading in the day side. Some people shade in the day side. I think it makes them all kinds of mixed up. And the way I can be able to just diagram this is I drew the inner circle in green, and however you see the inner circle is what you see from Earth. All right, you got to kind of pretend you poke your head through the Earth and you're looking at these circles through the board. All right. So that's 8 and 9 together. This right here is 8. And then this right here is down at the bottom. Can't really see my cursor on the screen. Is 9. Can I make a comment? No. So now the ones you are working on today. Number 10, draw a diagram for a solar eclipse. Draw a diagram for a lunar eclipse. Include the umbra and penumbra in your illustration. Where could I find that? I didn't post it as notes because we did it this week. But if you go back to, I believe it was Tuesday's stream. Diagram of eclipses. Diagram of eclipses starts at minute 8. So here's an old stream. Actually, if I set it to minute 8, it should be right there for you. There. Go to minute 8. If you go to minute 8 from the stream on March 31st, you will find that diagram in there. Okay. And that diagram complete looks like this, right? Solar eclipse, you have the moon in between the sun and the earth. At a new moon, lunar eclipse, you have the earth, you have the moon behind the earth in a full moon. Okay, the direct shadow behind an object is called the umbra. The indirect shadow blocking indirect light coming at a different angle is penumbra. Okay. Why are lunar eclipses more common and why do they last longer? Because the Earth is larger, there's a greater chance that you're going to have the moon's orbit line up with the Earth's umbra. And because the Earth's umbra is so much larger than the moon's, lunar eclipses happen longer. Okay, solar eclipses are much shorter because the moon is much smaller. They're much rarer because the umbra is so small. You have to have new moon happen at just the right moment with just the right tilt in the moon's orbit of the Earth with your location on the planet. So rare that our next one in Coventry is in 2079. And the last one, I couldn't even tell you when the last one is. You'd have to go back to timeanddate.com and just keep working backwards. All right? Looking at hundreds of years between total solar eclipses. It's a lifetime event. So if you ever get a chance to see one, hopefully 2079, take it. Just like how comets are kind of lifetime events too. You guys weren't born for Comet Hale-Bopp. We talked about comets earlier, but Comet Hale-Bopp in the 90s was pretty crazy. That was in the night sky for about a week. Double tail. Hi, Logan. Number 11, and I'll kind of work with this one with you a little more in depth. Describe how to make a solar and lunar eclipse model using materials found in a science classroom and explain how it's accurate. This one's tough because modeling eclipses, the assignment, was supposed to be an in-class, literal modeling assignment where you and a partner would use a tennis ball and a marble to make a lunar and a solar eclipse, where the tennis ball would be the Earth and the marble would be the moon. So number 11 is going to be kind of tough because you don't have that experience. But again, I would maybe think about how you did modeling the SEM system. I would think about those materials and how you could show a larger object eclipsing a smaller object. So maybe I'll kind of just diagram it to you. You said BB-8 in a tennis ball. You'd have to make it a bigger BB-8 somehow. But the right idea, Rainy. Maybe BB-8 in a marble. Maybe BB-8 in, I don't know, something a little smaller than a tennis ball. BB-8 in a Nozzlebot. You guys remember that? So this is number 11. I'm going to diagram it, but then kind of explain it too. So I would, and this is kind of what I was doing for your lab, and you can use this or you can use whatever you want to come up with on your own. Like Rainy, you said BB-8 in a tennis ball. You can make sure it's a little more accurate, but you can do that. An Nozzlebot it is. All right. I had for you guys lamps. And the lamps would be attached to a table. It had no cover, it had no shield. Like you've seen my lamps in the classroom. All right, this lamp had no shield. This lamp would just be radiating in all directions. This would act like our sun. And then, what color is a tennis ball? Something like this. It's a little too big. I'd have a tennis ball. Yeah, there's a tennis ball, right? Looks a little yellow, but whatever. That tennis ball would represent Earth. And then with this tennis ball, I would also then have a marble, and that would be the moon. And what would happen, and you would actually see it, is obviously that the Earth would then eclipse the lamp if you held it just right at just a certain distance, a couple meters away, and it would produce an umbra, and it would eclipse the marble. Okay? And so this would end up being a solar eclipse. This is a solar eclipse because the Earth's umbra, again, direct shadow, is blocking the sun to the marble. And doing something like this tells me two things. One, it tells me ratio, size ratio, that the sun is large, the Earth is larger than the moon, but smaller than the sun, and the moon's the smallest object here. However, you're also showing me that the Earth and the moon are closer in size than the sun and the Earth are, right? It also shows me that you're able to manipulate and show me an eclipse and the positioning of that eclipse. So this is a solar eclipse. This is just one example. Oh my God. This is not a solar eclipse. I failed. This is a lunar eclipse. I failed. So this is a lunar eclipse because the Earth's umbra is blocking the sun to the marble. Okay? If I would want to make this a solar eclipse, though, now the moon is in front of the tennis ball. and its umbra falls on one small point on the Earth. And so you could actually hold the marble in front of the ball and see a little shadow on the tennis ball. And that little shadow would be where your tiny little fibers on the tennis ball would be experiencing a solar eclipse. So this is now a solar eclipse because the moon's now umbra is blocking the sun to the tennis ball. Blueberry and tweezers. Sure. This would be a new moon because it's a solar eclipse because the moon is closest to the sun at this point. All right. Lunar eclipse equals a full moon. All right. So that would be number 11. Again, trying to use something real life to manipulate to be able to observe an eclipse. So I gave you a simulator in modeling eclipses. Again, I intended a marble and a tennis ball and a lamp to help you do this, but we had to use virtual means because we're not in the classroom. All right. So that was 11. 12, 13, and 14. Draw a diagram of the high tides and low tides on the Earth according to the 4 different positions of the moon revolving around the Earth and the Earth revolving around the sun. That one's a little wordy. Draw a diagram of the high tides and low tides on the Earth according to 4 different positions. I'll come back to that in a second. I hope you do number 12. 13, why do 2 high tides and 2 low tides occur on the planet simultaneously? And 14, what is a spring tide? What is a neap tide? What lunar phases are required for each? So 13 and 14, you're going to kind of do on your own. And again, I've given you some materials already. If I go backwards in time a little bit. Diagram of tides and special tides. You go back to March 26 posting. So I'll just take this right here. Go to March 26th. March 26th, we'll have your diagram of tides. Why are there 2 high tides and 2 low tides? Because the moon's gravity results in 2 places where there is high tide. And if you have 2 places where there are high tide, then you have 2 places that are losing water to those high tides, and those become low tides. So high tide and low tide alternate around the surface of the Earth. And because the Earth rotates and the moon kind of stays in that one phase per day, you are going to have alternating tides every 6 hours because it takes 24 hours for the Earth to do one rotation. All right, so use that picture to help you do number 13. Number 14, what's a spring tide and what's a neap tide? Spring tides are more extreme tides. Neap tides are more minimal tides. You need to have a straight alignment for sun, earth, and moon because you need the moon and the sun's gravity to line up in high tide. But if you have a neap tide where the sun and the moon's gravity are at a right angle, their high tides that they make will cancel. The moon is responsible for tides on the Earth. It is closer. It is more stronger in terms of its gravitational attraction. However, the sun, being so large, even though it's so far away, still has some small effect on the tides. So when the moon is at a certain position at the quarter phases, like right now we are in like a neap tide point in the month, then you would have the sun pulling back some of that water from high tide, and that water would make a higher low tide and make the high tides lower themselves. All right. John, do we draw a diagram for 13 and 14? I think it would be helpful, but I would still answer the question in sentences. Because when you draw the diagram, again, you are reviewing it. You're forcing yourself to review it slowly, and that's helping you better and hopefully your attention. How would an eclipse in a binary system work? Do you see my latest Ask Mr. G video, John Leach? I think you asked that other question. Can't remember. Eclipse in a binary system, you would need, like Hayden kind of says, a one really big moon really close to your planet. Almost, you would need a moon that's like almost a 2-to-1 aspect ratio, because you'd assume the sun, you'd have two suns of similar size. So you just need a really large moon, which would probably destroy, the planet. The moon's shadow is called an umbra. So that was 13 and 14. Did 11. I referred you back to that diagram for 10. So we only got like 5-ish minutes left. So doing number 12. 12's kind of a repeat. Draw a diagram of the high tides and low tides on Earth according to the 4 different positions of the moon revolving around the Earth, and the Earth revolving around the sun. That's going to kind of lead you to spring tide, neap tide. I don't know why I phrased number 12 the way I did, but I imagine I just wanted you to practice kind of understanding where you can have differences in high tides and low tides, because this right here is going to end up resulting in spring and neap. Oops. So number 12, Eric, I would use this right here. Go back to March 26th. Use the tide diagram of tides. It would also kind of work with 12. All right. So I'm going to draw 4 Earths. Oops. Just to kind of show that this is differences in space, because space has no reference unless it's relative. The sun's over here. So I'm going to draw the moon here. I'm going to draw the moon again in its counterclockwise orbit here, here, and then here. So I have 4 options. All right, each one is just kind of built off the next one, moving in a counterclockwise orbit. Oops. Sorry, Hayden. Thank you. I fixed it. Thank you. So 4 different options. I'm again just kind of helping you figure out where high tide and low tide is. I didn't mean to say include the sun, only just as a marker, because I want you to do spring tide and neap tide obviously later on in the study guide. So in these different positions, find high tide first. So high tide, water's getting pulled towards the moon, right? And every single one, I'm going to try and find high tide first, because that's what you should be doing. John needs a break. So, high tide here. High tide there. When you find high tide, obviously on either side, that water has to come from somewhere. So we mark each one as low tide. Now comes the big question. And in roll tide, this question was a follow-up in the explain section. I think it was the last question in the explain section. I asked you if you were facing the moon, what tide would it be? Almost all of you were right. You said high tide. Good. Then I asked you, well, what tide would it be if you're on the opposite side of the planet? You were turned halfway and you were no longer facing the moon. Well, you're still in line with the moon. And the moon can't reach all the way to the other side of that planet, so this water stays higher. So if you are in line with the moon, you are in a high tide. If you are at a right angle with the moon, you are at a low tide. So when we're talking daily tides, these are daily tides. There are 4 a day. There are 2 high tides. There are 2 low tides. All right. And they alternate high tide to low tide, back to high tide, and finish with low tide. Okay. To go from one tide to the next will take 6 hours. To go from the same tide to the same tide would take 12 hours. To complete the entire day, it would take 24 hours. Okay? So this is what I would include with number 12. I wouldn't get in depth on spring tide, neap tide, even though I could even use this diagram to kind of pick out where spring tide, neap tide would be if the sun's off to the left. Okay? Obviously, if I numbered them or give them a letter, so position A, you would have a spring tide. Position C, you would have a spring tide. Position B would be a neap tide, and position D would be a neap tide. If the sun, earth, and moon are in a right angle, it's a neap tide. If the sun, earth, and moon are in a straight line, it is a spring tide. If you are in line with the moon, when the moon is in line with the sun, then you will have a very extreme set of tides. Your high tide will be much higher than normal. But if you are at the right angle of the sun, the moon, and the earth, who are all in a straight line, you will be at a neap tide, and the high tide will be much lower than normal. Low tide will be higher. Okay? But that's kind of going into number 14 at the end. I just want you to know for number 12, there are 4 tides a day. They alternate. There's 2 of them that repeat. 6 hours between tides, 12 hours to go from the same tide to the same tide. All right? There's 4 a day because it takes 24 hours. All right? And there's 4 a day because the moon influences the high tide, and high tide is the side closest to the moon and the side opposite the moon. All right? The sides that don't have as much water, it's going to be low tide. So you're finishing up the study guide, and you're studying it for the weekend, getting it ready. Make sure you're ready for Monday. Okay? Tomorrow, you do not have an in-school day. It's not an instructional day. There's nothing new. All right? I've given you the tools and the guidance, hopefully, for you to finish this study guide. If you have questions, obviously, you can still reach out to me, and I'll help you. All right? Or you can rewatch these streams to help you. All right? But have the study guide ready for Monday. You should be reviewing it over the weekend for the review on Monday. All right, kind of like how Mr. Howman yesterday did it, and hopefully you were participating in it. A quizzes live through YouTube. I'm going to be doing the same thing on Monday. I'll have a quizzes after we review the study guide all the way through 1 through 14 one last time. All right, but again, any questions you got to ask. Tuesday will be the test itself. All right, in a Google form in Classroom. 15 questions, 1 part multiple choice. The other part would be a justification. All right. Why did you pick the answer you did? All right. And then Wednesday, we'll kind of just start getting into the idea of outer space. And then you are off Thursday and Friday of next week. So there is no DNA sheet this week. There is no DNA sheet next week. You have a test to prep for this week. You have a test to take next week. Plus, it's also a very shortened week. All right. We'll do DNA sheets starting up again that week after. All right. And going back to DNA quizzes. You'll also be kind of getting into, again, the rest of the solar system. At some point, we'll be talking about stars. I put out a recent video. It came from either John or I can't remember who said it. Eric, John, somebody in chat a couple days ago. Does the sun have a shadow? Go watch it. The sun itself doesn't have a shadow, but there is a shadow involved from the sun that may help us find life on other planets. Pretty cool idea. Check out the links I put in the description because that's where you can find more information. Yeah, I think Hayden asked about the moon blowing up. So if you have any other questions as we move forward, I'll try and pull different questions. You can make comments on the videos about other questions. Maybe I'll do a little bit extra research. All right? Any final questions? I don't think I missed anything. Anything? Got 14 of you. A peach parakeet. Nope, thanks, bye. Okay, Ryan. I'll catch you later. Have a good weekend. Anyone else? Does a planet with a ring have an equal tide? I would assume the ring doesn't have enough mass to really influence the tides in different directions because the ring would have equal mass in all directions. So you wouldn't really see a difference in the tide. See, Eric. But you would probably have your star causing the tides. Bye, Downey. Alright, guys. Have a good weekend. Send your questions if you got them. Bye. You like it, Rainy? My wife helped me make it.